Every parachute must deploy perfectly. But behind that moment, there's a long and careful parachute packing process that's done completely by hand. But what if this process could be automated?
Today, parachute packing is still done manually. It is labor-intensive, time-consuming, and requires skilled operator. One of the biggest challenges is consistency. Even small mistakes can affect development safety. In fact, parachute riggers are often operating at only 60 to 70% capacity.
Our goal is to explore how robotics can assist in this process. We're focusing specifically on automating the last step, which is the line stowing step.
These steps involves pulling bundle line through loops in a precise zigzag patterns. It sounds simple, but it is actually very complex.
The biggest challenge comes from the nature of the materials that we are working with. Parachute lines and fabric loops are flexible and unpredictable, especially under heavy force when stowing the lines. This makes perception and control extremely difficult.
To address this, we designed a vision-guided robotics system.
On the hardware side, we iterated through multiple designs. A hybrid gripper mounted to the main arm was designed for stable line handling, and 2 high-force sidearms were built from scratch to pull the lines through the loops. This allows the sidearm head to generate enough force while maintaining precise control.
For perception, we use a YOLO V26-based pipeline. The side camera performs object detection to localize the loop positions, while the top camera is used for loop state estimation. This unified detection and classification pipeline enables reliable real-time perception for the manipulation process.
To develop the software in parallel with the mechanical system, we built a digital twin that allowed us to test and refine the control logic before the hardware was ready.
Once loops are detected, their 2D image locations are transformed into targets in the robot's workspace.
A central coordinator then guides each stow through a defined sequence of states, including positioning, insertion, handoff, and verification between the 3 manipulators.
Our system is able to complete the line stowing process in a way that's comparable to how it's done by humans. Our system improves the consistency of successful stows and reduces physical effort on the operator. This demonstrates that robotic automation in this field is feasible.
This project represents a step towards automating complex textile manipulation, and it's opening up the door to safer and more efficient systems in the future.